All right. So, yes, ma'am. Yeah. So, yesterday we were talking about remainder theorem after we did synthetic division. Now, what was so important about remainder theorem? So, like on page 9, we did those two problems together. What was kind of the remainder theorem? Does anyone remember? So, it has to do with the remainder when we do the division. But what specifically? Remember, it's like an easier way to get the remainder without actually having to do the division. But what did we exactly do? Plug in what? What part? What X? What's the such name for it? The the divisor's the factor, but what happens when we change it? So we solve it for X. It's called the root. So we're plugging the root into the original function. Okay? And remember, we plug the root in for X into the original function and we evaluate it, it'll give us our remainder. Now, why is that important? First off, on your test, there will be questions of what is the remainder of this function with this root. We divide by this root. Okay? That'll save you time. Don't have to do all the division. You just gotta plug it in, evaluate it, you got your remainder. Okay? Why else is it important? It tells us whether the binomial is a factor of the big polynomial or not. Alright? Because I've been using factor a lot. So like I would say x minus 7 is a factor. That's not necessarily true. Can anyone tell me what a factor actually is by definition? So to give you guys a hint, 5 is a factor of 25. Right, it's a value that can divide evenly into another value. So if it divides evenly, that means it has a remainder of what? 0. So if it divides evenly, it has a remainder of 0. That's what's important, okay? That helps us determine whether a binomial is a factor of the bigger polynomial. If we put it into the remainder theorem and we get a remainder of 0, it's a factor. If not, it's just a binomial that we divided into it. All right? That's all it is. So, look at page 10. All right? So this was my second periods, but y'all's are pretty much the same thing. So remember, exercise 3, I wrote out that, it's a factor because, I'll rewrite again. So, x minus a is a factor of p of x if the remainder is equal to 0. All right? If the remainder is not 0, it's not a factor. Another way to think about it is that if we factored, like actually went through and did big X and everything for, this trinomial here, that means one of our factors would be x minus 3 as part of our answer. So we factored it. Okay? That's another way to think about it. So let's do 1 or 2 examples here just to make sure that you guys are good with how to determine if it's a factor or not. Okay? So look at exercise 4, letter A. So we're going to use the remainder theorem because that's the easiest way to do it. All right, less work. Sometimes the shortest way is the smarter way. Sometimes it's not, but in this case it is. So we're going to say whether x minus 3 is a factor of p of x equals x squared minus 11x plus 24. So first off, what is my root, Ryan? Okay. So, Ryan, what's the root? 3. So you've set x minus 3 equal to 0, and it's 3. All right. So we're going to plug in 3 in for the x. So we get 3 squared minus 11 times 3 plus 24. And then we're just going to evaluate it. So you can either put it in your calculator, or honestly, we can do a quick eval on our own. So 3 squared is what? 9. What's negative 11 times 3? Negative 33 plus 24. So 9 minus negative 33 is negative 24 plus 24 is equal to 0. So remember, this is our remainder. So as a show of thumbs up or thumbs down, so thumbs up it is a factor, thumbs down is not a factor. What do you guys think? So is it a factor? Is it not a factor if it has a remainder of 0? It is a factor. So if it has that remainder of 0, it is a factor. So yes, x minus 3 is a factor of x squared minus 11x plus 24. That's right. Yeah. All right. Any questions on that one? All right. Let's do one more. So letter B. So Ryan, pick someone to tell me the root of this one. All right. Zach, what's the root? Good. So x is equal to negative 5. So we're finding p of negative 5. So this would be 2 times negative 5 squared plus 9 times negative 5 minus 2. Bless you. So what's negative 5 squared? 25 times 2. So this is 50. What's 9 times negative 5? Negative 45. And then minus 2. So 50 minus 45 is 5. Minus 2 is 3. So 3 is our remainder. So is it a factor or is it not? Thumbs up or thumbs down? Go. It definitely is not. So no, x minus 5 is not a factor. So does everyone... I don't even want to know. So does everyone understand how you figure out if a binomial is a factor of a bigger polynomial? So again, all you do is take the root, plug it in to the original. If it equals 0, it's a factor. If it's any number but 0, it's not a factor. All right. Okay, last thing I want to talk about for 3.4, and then we'll get into everyone's favorite quadratic formula. I want to go over exercise 5 because you will see a problem like this on your test. Okay? So, it's asking what is the value of k that will make x minus 4 a factor of this function, where k is the coefficient of your x value. All right? Now, it's pretty much the same process that we've been doing. It's actually not a very hard problem if you just think about it. So, let's just start with what we know. We're still going to use remainder theorem. So, Zach, pick someone to tell me the root of this. All right. So, what's my root? 4. So, x is equal to 4. So, we're still going to plug in 4 for x into the function. So, I'm going to have 4 squared plus k times 4 minus 52. All right. Now, we got it down so there's only one variable. So if we add if we set this equal to something, we have ourselves an equation. A pretty simple one at that. What do you think, if I want it to be a factor, I'm going to set this equation equal to? 0. Good. So we just got to set it equal to 0, simplify, solve for k. So what's 4 squared? 16 plus. I want to rewrite k times 4 as 4k. And then minus 52 is equal to 0. 16 minus 52 is negative 36. This would be 4k minus 36 is equal to 0. How do I solve for k? What's my next step? Plus 36. So I get 4k is equal to 36. So let's go with Frederick. What's k equal to? 9. Good. So your k value has to be 9. So what this means is x minus 4 is a factor of x squared plus 9x minus 52. So that's if I plug the 9 in back in for k. So this would be the polynomial that x minus 4 is considered a factor of. So again, this looked messy as crap from the way they stated it, but in reality, it's you plug in the 4 for x, and then set equals 0 solve for k. That's all I had to do. All right. Any questions on remainder theorem? Yes. When Tyreek gets back. All right. So here's what we're going to do next. Take out that packet that I had you guys grab. All the way around the All right. So take out that packet that you guys had to grab, the quadratic review. So, like I said, guys, quadratic formula is going to play a really big part in our next lesson. So that's why I want to take a day to just review it, okay? Because this is a Math 2 concept, but for some of you, it's been like a year since you took Math 2, all right? And I know some of the teachers you guys had for Math 2, so I'm not going to say anything else from that, all right? So, just to review, so somewhere on your paper, you need to write this. The quadratic formula is x equals negative b plus or minus the square root of b squared minus 4 ac all over 2a. This is the quadratic formula. And that is when you are given ax squared plus bx plus c is equal to 0. All right, so ax squared plus bx plus c equals 0. That's what you start with. And then you would take the ABC values, which are numbers, plug them into the formula. Okay? So, again, A, B, and C are what? Numbers. No letters go in that formula. All right, so the biggest mistake I see people make is they start throwing X's in here, and then it's a mess. You're solving for X, so an X should not be in there. All right? It's just numbers. Okay, so before we even get into quadratic formula, we first need to review how to simplify a radical. Okay? Now, why am I doing that? Because in Math 3, you don't give me a decimal, you give me a simplified radical. Especially once we throw i's in there. All right? So we're just going to review, I'll bring it up in a second. So we're just going to review just how to simplify a radical. Okay? So I'm going to do one, and I'm going to have you try one. That's how we're going to play that. Okay? So when you're going to simplify a radical, all that means is you're taking out all the perfect squares. And then whatever's left over is what's left under the radical. Okay? So you start by just figuring out some factors of 32. All right? So someone raise your hand and tell me one set of factors for 32 besides one itself. So there are two numbers besides 1 and 32 that multiply to give me 32.
2 and 16.
2 and 16. I heard 4 and 8. And that's pretty much it. Well, there's probably more, but this is enough. So, I'm looking for perfect squares. Out of these four numbers, what are perfect squares? So, what numbers specifically are the perfect squares? What do I mean by perfect square? So, what I mean by perfect square is if I took the square root of that number, I would get a nice whole number, not a funky decimal. 4 is a perfect square. What's another one? 16. So, guys, being able to recognize your perfect squares at least up until 10 is pretty important. So like up till 10 squared. So in other words, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100, 11 squared is 121, 12 squared is 144, 13 squared is 169, 14 squared is 196, 15 squared is 225, 16 squared is 256, etc., etc., etc. All right. I've done it so often, guys, especially in college. You just start memorizing them. You guys at least need to know up till 10. Honestly, 12 if you're pushing it. All right? Because those are basic multiplication tables. You guys learned your multiplication tables up to your 12s, or you should have back in elementary school. So, at the very least, you should know up to what 12 times 12 is. Okay? All right. So, then what I tell my students is when you get here, you want to pick the set of factors with the highest perfect square. Because you can really pick any of them as long as they have a perfect square, but the higher you pick, the less steps you have. Okay? So, which one's my highest perfect square? 16. So I'm going to pick this set. So what I'm going to do is I'm going to rewrite the square root of 32 as the square root of 2 times 16. Which, by laws of radicals and everything, we can separate that multiplication into the square root of 2 times the square root of 16. We can actually break it apart into two separate radicals. Now, square root of 2, we know it's going to be a funky number, so we're going to leave it alone. What's the square root of 16? 4. So we have the square root of 2 times 4. So we would rewrite this as 4 square root of 2. Now, when you finish, you want to make sure that what's under the radical has no more perfect square factors, which 2 definitely doesn't. It's only 1 and 2, both of which are not perfect square. Well, 1 is, but, 1 square root of 1's 1, so it's not going to matter. Okay? Does everyone kind of understand what I did here? Now, let me show you what would happen if you picked 4. All right, you would just have to do it twice. Okay? So, this is just to show you that even if you don't pick the highest, you can still do it as long as you have a perfect square. So, let's say I picked 4 and 8. I want to separate this as 4 times 8. So, I can make this as square root of 4 times the square root of 8. So, what's the square root of 4? 2. So, I get 2 square root of 8. Now, we need to double check that 8 doesn't have any more perfect square factors. So, what are 2 factors of 8 besides 1 in itself? 2 and 4. Is there a perfect square in there? Yes. What number? 4. So we got to do it again with 8. So we would have 2 times the square root of 4 times 2. So this would be 2 times square root of 4 times the square root of 2, which we already know the square root of 4 is 2. So this would be 2 times 2, square root of 2. And then what's 2 times 2? 4. So you would still end up with 4 square root of 2. All right. The only difference between this one and this one is this one had an extra step. You got to do it twice. Okay. So it doesn't matter which set of factors you pick as long as one of them is a perfect square. I just say shoot for the highest one because it's less work. That's right. All right. So what I want you guys to do is on your own, and you can work with your group on it, honestly. But I want you to try the next one. So with 128. So find some factors for 128. All right. See if you can get the highest perfect square. And then simplify the radical. So I'll leave this one up as an example. you're trying to simplify 128, start by finding some factors in 128. Which, guys, if 128 is an even number, what's automatically a number you can divide by? 2. Yep. So start there. Okay. First thing you want to do is factors of and we're looking for a set of factors so let's go
Oh, okay.
When you're stuck, talk to your group mates. Remember, you're looking for a perfect square. Doesn't necessarily be the highest.
Yeah.
So two. No. I just showed it as like a counterexample of the height. So like, the first way is probably the more ideal ones, but the second was like, okay, let's just say. I was saying that's still possible. Yeah, it's still possible. And honestly, if you picked this one, it's not messing up, you just gotta do much. So remember, guys, your end goal is to make sure that the number under your radical has no more factors that are perfect squares besides 1. 1's going to be the only one. So you want to take this word out, the perfect square out. Okay, so which of these would have your highest perfect square? Take one and mix that. Now you can use any of the other ones, not that perfect square. You just would have like 2. Alrighty, ladies and gents, let's come back together because it looks like all of you guys got it. So let's go with Jackson. What is one set of factors for 128? Okay, pick someone and tell me another pair.
4 and 32.
4 and 32. Okay, Zach, pick someone else who has not talked yet today. Caden has talked.
Oh.
Yeah.
Dylan.
All right, so Dylan P. What's another set of factors? 8 and 16. All right, we'll stop there. Now, there is a perfect square in all three of these. Which one has the biggest? 64. So that one's going to be the one we use. So I'm going to rewrite this as a square root of 64 times 2, which we can then rewrite as a square root of 64 times the square root of 2. What's the square root of 64? 8. This would be 8 times the square root of 2, or just 8 square root 2. And that's it. Now, that's if it's a positive under the radical. Now, negative under the radical is pretty much the same thing, except there's one more thing we got to do first. So, if you have a negative under your radical, you talked about this back in math 2. Does anyone remember what you got to take out to make it positive? So, in other words, technically, if you put the square root of negative 200 in your calculator, you will get an error because it's not a real number. It's called a complex number or an imaginary number. So, in order to make it so it's not negative under there anymore, you've got to take a I out. So you got to take an I out. So in order to get rid of this negative right here, you bring an I outside of it. So this will be I square root 200. I is just a mathematical letter that we use to emphasize that it's an imaginary number. All right, yes, in math there is imaginary numbers. There's real numbers, there's imaginary numbers, and there's complex numbers. And then from there, it's business as usual what we just did. All right, we then just simplify the radical. We just got to make sure the I is included in our final answer. All right, so let's go with Caden. What's one set of factors for 200? 102. Good. Now, is either one of those a perfect square? Yes, 100 is. So I'm assuming since, the other factor is 2, that's your highest. Okay. So we're going to go ahead and rewrite this as I times 100 times 2. So this will be I square root of 100 times the square root of 2. What's the square root of 100? 10. So this would be 10I square root of 2. All right. So just be careful and make sure that if you see a negative under that radical, which you will see when we start doing some quadratic formula, you take that I out first before you start simplifying. Okay? So again, negative under the radical, you take an I out. Why is that what? So I is a mathematical letter that we use to represent imaginary numbers. Because technically it's not big. It's called some mathematicians wanted to figure out what happens when they don't have real solutions, so they end up with imaginary numbers. So there you go. Well, they're long. So now, you guys feel comfortable with simplifying radicals? Okay. So now we're going to swing into some quadratic formula. All right. So look at number 5. Now the quadratic formula should be at the top of your paper somewhere. So remember, it's negative b plus or minus the square root of 2a Oh Lord, that's not even right. Negative b plus or minus the square root of b squared minus 4ac all over 2a. All right. So just look off the chat. So first things first. Remember, you got to have it in the form ax squared plus bx plus c is equal to 0 so that you can get your a, b, and c values. So if we're looking at this problem here, what would be the first thing I need to do? What do you guys think? Move the negative 3 to the other side. How? Add. And what do I add it to? The 1. So if I do that, this is 9d squared plus 12d plus 4 is equal to 0. All right. Now I can get my A, B, and C values, which I always like to just write them off to the side just so I know what I'm plugging in where. Okay. So, heads up, my dears. Let's go with Zach. What's my A value? Zach is definitely not here. Okay. Well, let's go with Skylar. What's my A value? So if you look at ax squared plus bx plus c, it's 9. So, guys, with your values, A is always connected to the x squared, B is always connected to the x, C is always the constant. Okay? Always. So A is your 9. So Skylar, pick someone to tell me what the B value is. 12. Layla, pick someone to tell me what C is. 4. Good. So I'm going to plug it into the formula negative B plus or minus the square root of B squared minus 4AC all over 2A. I'm going to plug it in as is. I'm not going to do any simplifying. All right. So this will be negative 12 plus or minus the square root of 12 squared minus 4 times A, which is 9, times B, which is 1, all over 2 times 9. That's all I did. I've done no simplifying. I just put the values in the formula as is. And take note, the negative in front of the B at the beginning of the formula is part of the formula, so you have to put a negative there. If the number's already negative, you still got to make it negative again. So it would be like negative times negative. You'll see it in a second.
Isn't that supposed to be 4? It's not a 9.
That's 4.
No.
That, yeah. That's called Miss Murphy made a oopsie doodle, and there we go. All right. So now we're going to do some simplifying. So someone raise their hand and tell me one place where I can simplify. Dylan. So I will just go ahead and just put all of this, like what's under the radical only, not including the radical, in your calculator. All right. But be careful and make sure you put whatever's being multiplied in parentheses. So I'll put this in with you guys. Stop. So if I plug this in as is, this will be 12 squared minus, and I'm going to put parentheses, 4 times 9 times 4, close the parentheses. So it goes under my radical is 0. Sorry, I know what the way the projector is. Yes. Yeah. So what I'm going to write here is negative 12 plus or minus the square root of 0 all over, what's 2 times 9? 18. Now, once I got everything simplified so that I have a singular number under the radical, and then the other 2 spots is just singular numbers, I can start simplifying the radical and do some more simplification if need be. So if I simplify the radical, what's the square root of 0? 0. So the square root of 0 is 0. So this would be negative 12 plus or minus 0 all over 18. Now, does anyone remember what I need to do to take care of the plus or minus? So we kind of talked about this last week when I gave you like that one warm-up. So someone besides Dylan, I know you know. So does anyone know what I need to do next to kind of get rid of this plus minus? What does plus minus even mean? Plus and minus. Sorry. Yeah. Plus or minus, plus and minus. It's kind of the same thing. It just means break it apart. You're adding for one, you're subtracting for the other. All right. So plus or minus is just shorthand to say you add one, subtract the other. So if we break this apart, this would be negative 12 plus 0 over 18, negative 12 minus 0 over 18, which both of them, if you add or subtract 0, you still get the same thing. So this would just be negative 12 over 18. So we're just going to have one answer here instead of two. Now, what's negative 12 over 18? What does that simplify down to? Negative 6/9, or if I simplify it again, negative 2/3. Good. So you can divide both of these by 6. So if I divide both of these by 6 over 6, I get negative 2 over 3. So x or d would be equal to negative 2 over 3. That would actually be a root to that quadratic. That's all you gotta do. Now that seems like a lot of work, but I also took a lot of steps, like with just writing out each individual step. All right. The better you get at it, the more you can shorthand it. Okay. All right. Any questions on that one? All right. Let's try another one. So, guys, today is going to be pretty quadratic formula heavy. We're just going to be doing a lot of examples together. So when we do our lesson tomorrow, where you're going to have to do the quadratic formula again, but as like kind of an afterthought, that's the last thing you got to worry about. Okay. So let's look at number 7. All right. So let's work through this together. So Mackenzie, what's my first step before I can even start putting stuff in the formula? Right. Good. So we're going to add the n to both sides so we can get one side equal to 0. So this would be 5n squared minus 29n plus 20 is equal to 0. All right, Mackenzie, pick someone for tell me what a, b, and c is. So Tyreek, what's my a, b, and c values?
Your A is 5.
Mm-hmm.
Your B is 30.
Not 30. Look at the blue. That's what we're using.
Oh, my bad.
You're good.
29.
Not just 29, but
29N. No.
What's in front of the 29?
Negative 29.
There you go. And then what's the last one?
20.
20. Good. So guys, don't forget to include the signs in front of the number. That's important. Now, I'm just going to plug it straight into the formula. So I have a negative times negative 29. That's what I meant when I said if it's a negative number, still got to apply the negative to it. Plus or minus the square root of negative 29 squared minus 4 times 5 times 20 all over 2 times 5. And so all I did was put it straight into the formula as is, no simplifying yet. I just replaced the values in the formula with the values that the equation gave me. So what's one place where I can simplify? Let's go here. Leslie. The radical? Yeah. So we can start by simplifying everything that's under the radical. So Leslie, if you put that in your calculator, what do you get? Right. So I have something plus or minus the square root of 441. And again, you just get that by putting that all in your calculator. And again, make sure you put parentheses around the multiplication bit. Also, make sure you put parentheses around the negative 29 before you square it. If not, it'll turn it negative and your answer will be wrong. Remember, if you square a negative number, it's still positive. Where else can I simplify? Tyreek.
The negative 29.
Right, so we're doing a negative times a negative, so what happens to it,
It
Tyreek?
makes it positive.
Good. And then the last place we got is 2 times 5, which is 10. Now, here's my advice to you guys. We have a big number under the radical where, you may not know off the top of your head whether it's a perfect square or not. Check it in your calculator, because if you're like assuming that it's not a perfect square, you'll probably be doing a lot more work than you need to. So my advice to you, always check to see if it's a perfect square, because if it is, it's a lot less work than if it isn't. Okay. So I'm going to check real quick by hitting second and then the x squared key. I'm going to type in 441. Which, look at that. It is a perfect square. It's not a weird decimal. All right. It's just a nice whole number. So I'm going to simplify the square root of 441 to be 21. So it's be 29 plus or minus the square root. Nope, not square root. Square root's gone. Plus or minus 21 all over 10. What's my last step, Julian? So I need to take care of the plus or minus. How do I take care of the plus minus? Right. So we break it apart to where we're adding the 29 and the 21 over 10, and then we're subtracting the 29 and the 21 over 10. So 29 plus 21 is 50. It's 50 over 10, which 50 over 10 simplifies down to what? 5. 29 minus 21 is 8. So we have 8 over 10, which, what number can I divide to both 8 and 10 evenly to? 2. So if I divide both by 2, what's that give me? 4/5. Good. So n is equal to the set of 4/5 and 5. So that was one where we had 2 answers. Now, the ones that we've been doing so far have had nice numbers. Okay? Nice numbers, perfect squares in there. We actually had to do some computation. Let's look at some ones where you can't simplify the radical, or the radical is not a perfect square, I should say. All right. So let's look at number 9. Yeah, let's look at number 9. All right, so Layla, tell me my first step here. We gotta get equal to 0, so what do we need to move? Good. So we add the 3m to the 6m, and we get 2m squared minus 3m minus 1 is equal to 0. All right. ABC, it's 2, negative 3, negative 1. So I'm going to put it in my formula. So this would be negative 3 plus or minus the square root of negative 3 squared minus 4 times a, which is 2, times c, which is negative 1, all over 2 times 2, or 2a. So again, Just put in my formula as is. Done nothing simplifying wise. All right. Now, Dylan P, how would I simplify the negative times -3? It'll become positive. Good. This will be positive 3 plus or minus. Let's go Dylan L. If you evaluate what's under the radical, what number would you get? No, not on the bottom. Under the radical. Yeah. I think it's 17. Yeah, it's 17. All right. And then, like Dylan said, we would have the 4 on the bottom. Now, guess what? 17. We already know that's not a perfect square. But could we simplify 17? So if we figure out factors of 17, would there be a perfect square in any of those factors? What are the only two factors of 17? 1, 17. So we're done. All right. Now, that's our answer. Just to note, though, this is technically two answers, because if you separate the plus or minus, this would be 3 plus square root of 17 over 4, 3 minus square root of 17 over 4. All right, so just make note that even though we shorthand it, so it looks like one answer, it's actually two. It's like a 2-in-1 deal. So guys, if you know what's under that radical is going to be ugly if you put it in your calculator, don't even bother. Check to see if you can simplify it. If you can't, leave it as is. You're done. All right. Any questions on that one? All right. Let's look at one where you actually got to simplify it. So let's try 12. So number 12. What is my first step, Lainey? Right. Subtract the n squared to the 5n squared. So that gives us 4n squared minus 16n plus 11 equals 0. So A, B, and C, that'll be 4, negative 16, and 11. So if I just put it flat out into the formula, this would be negative times negative 16 plus or minus the square root negative 16 squared minus 4 times A, which is 4, times C, which is 11, all over 2 times 4. So again, my recommendation to you guys is at the very least, whenever you're writing out the quadratic formula, at least get it into this state first, and then you can either write it out one step at a time with how you simplify, or you can just simplify everything at once. All right, but at the very least, you want everything nicely into it without any simplification. All right. So let's go with Jordan. How would I simplify the negative times the negative 16? It'll just be positive 16. All right. Someone in their calculator put in what's under the radical and tell me what it is. So it'd be 80, which is correct. And then 2 times 4 is 8. Now, this is one where we got to do a little bit of grunt work. So 80. Do you think that if I find factors of 80, I'm going to find a perfect square in there somewhere? What do you think? Yes, no, maybe? Yeah, I'm thinking yes. So off to the side, we're going to simplify the square root of 80. So we're just going to simplify the radical like we first started the class with. So someone raise your hand and tell me 2 sets of factors for 80. 2 and 40. What's another set? Dylan. 10 and 8. What's another set? It's almost side so
120.
4 and 20. That's one. What's another set? There's one more I'm looking for. 5 and 16. Good. So, out of all of those sets of factors, which number is my biggest perfect square? Well, we got 4. That's one perfect square, but I have one more in here. 16. So, out of those 2, which one's bigger? 16. So, we're probably going to be using 5 and 16. Now, again, if you used 4, that's fine. You just would have had to simplify it again. You would have had to simplify the 20. All right. So I want to rewrite the square root of 18, square root of 80, Lord, as the square root of 16 times 5, which is the square root of 16 times the square root of 5. What's the square root of 16? 4. So it's be 4 times the square root of 5. So over here, I'm going to rewrite this as 16 plus or minus 4 times the square root of 5 over 8. Now, we're not quite done our simplification because always check the 3 numbers that are not under a radical. If there's a number that can be divided into all 3 of those numbers, divide that into those numbers so that you get a more simplified version. So what number can I divide 16, 4, and 8 into evenly? 4. So you could have picked 2 or 4. If you picked 2, you would have just had to simplify it again. So if I divide 16 by 4, I get 4 plus or minus. 4 divided by 4 is 1. So it'd be 1 times the square root of 5. So I'm just going to write square root of 5 all over 8 divided by 4 is 2. And I'm done. Now, you may be wondering, like, why can we not simplify the 4 and the 2? It's because of that unspoken 1 in front of the radical. All right, so all 3 numbers that are not outside the radical, that are not under the radical, have to simplify in order for it to be simplified. Okay? That's kind of the rule of thumb. All right, any questions on that one? Okay, we're going to do one more, and this one's going to have an I in it, and then we're done. Okay? The last one. I just want to do one with an I in it. Okay? So, guys, again, we're doing all this. I know this is really dry today, but we're doing all this because I'm telling you, you're going to be using this tomorrow, but I don't want to have to spend a bunch of time going through how to do quadratic formula tomorrow. Okay? So tomorrow it should be like that if I have you do the quadratic formula. All right? So let's look at number 15. So number 15. All right. Now, remember the I is just the imaginary number, so you'll end up with a negative radical somewhere. So my first step is to subtract the 20x over. Now, do I have anything to subtract the 20x to? No, I don't. So I'm just going to kind of write it in there because there's nothing to subtract it to, so we're just going to put it in standard form there. So A, B, and C. A is 1, B is negative 20, C is 97. Plug it into the quadratic formula, I get negative times the negative 20 plus or minus the square root of negative 20 squared minus 4 times 1 times 97 all over
2 times. Hold up. Yeah.
Okay, I like 15 times I'll give us an I. So I'm gonna leave that set up. Y'all can finish that on your own. But let's set up 16. That's the one I can remember. I'll give you the setup. So okay.
So 16, subtract the 28x over, subtract it over. That's gone. I get 4x squared minus 28x plus 61 is equal to 0. A, B, C. A is 4. B is negative 28. C is 61. So this would be negative times negative 28 plus or minus the square root of negative 28 squared minus 4 times 61 all over 2 times 4. So this would be 28 plus or minus square root. Someone put what's under the radical in their calculator for me. All over 8. Promise, guys, it's the last one. I absolutely promise. I lied one time because I picked the wrong problem. All right, did anyone get what goes under the radical? Negative 192, good. All right, so we have a negative under the radical. So what's the very first thing we got to do to simplify it? Take an I out. So if you ever have that negative under the radical, take the I out first, make what's under the radical positive. So it'd be 28 plus or minus. Like, there's no rhyme or reason why there is. I mean, there is a why, but honestly, it will go like way over your head. So just know negative under the radical, just bring out an I. That's all you got to do. Okay. So 192 over 8. Now we can simplify the 192. So someone give me 2 factors of 192. So start by dividing it by 2 first. That's probably the easiest way. 36 and 2. Wait, 36? 96. Okay, that sounds about right. All right, now watch this. Since it's 96, that means we can also do 4 and 48. That means we can also do 8 and 24. We can also do 16 and 12. We can also do 32 and 6. And we can also do 64 and 3. Now, how did I know those off the top of my head? All I did was double these as I divided half these. All right, so if I told last week, I doubled these and I half these. That's the way to do it. Because it is true. So, what is my highest perfect square? 64. So I'm going to use the 64 and 3. So remember, we still got the I. So I got I square root of 64 times 3. So what's the square root of 64? 8. So this would be 8I square root 3. So I would rewrite this as 28 plus or minus 8I square root 3 all over 8. Now, last little bit to simplify. These 3 numbers here. What can I divide into all 3 of those numbers evenly? 4. So what's 28 divided by 4? 28 divided by 4, guys. 7. plus or minus 8 divided by 4 is 2i. Still got the square root 3 all over 2. That's it. So guys, just remember, if you got negative under your radical after you've simplified everything, like the number under the radical is negative, you got to take the I out first. That's how you take care of the negative. Does everyone understand that? All right. So you only got about 10 minutes left of class. So here's my recommendation to you guys. There's not really an assignment that goes along with this. What I recommend is all the ones that we haven't done, just work through them. Like if you have time later today or tonight, and again, it's not an assignment grade or anything, but just to make sure that you're solid on quadratics, make sure that try the ones we haven't done yet. And I will post the key to this online. So if you do it tonight, you can check yourself. Okay. Yes, ma'am. Sure. I'll count it as optional work. So if you finish the rest of this packet, I will count it as optional work. Also, just so you know, for 17 and 18, the discriminant formula is just what goes under the radical. So it's b squared minus 4ac. So when it's asked for the discriminant, you use this formula. It's just what's under the radical, b squared minus 4ac. It's actually easier. It's 2 problems like that. 2. I'm not doing anything with it. Yeah. All right, guys. So you guys got about 10 minutes. So you could probably finish up that problem that I started for you, at the very least. But yeah, that's quadratic formula in a nutshell. So how you guys feeling? You guys feeling more comfortable with quadratic formula at least? Good Lord, Layla.